Say you don't wanna be with me, but you miss me as soon as it's over. Your name lighting up the screen, but you never call when you're sober. You say you don't like the games, but you play me like there's no tomorrow. You should know that I'm fed up with your lies, so don't come closer. You know you hurt me bad and I have scars. I need some time to heal, so don't come over. Don't even bother calling, just get lost. I'm fine on my own, so don't even bother to come back, 'cause I'm done. I'm fine on my own, and boy, your pretty little lies are getting old. All the nights I have wasted on you are gone, 'cause we are through. All the nights I have wasted on you are gone, 'cause we are through. You say you don't wanna be a thing, but I'm not the one who's calling. I'm tired of waiting for you to change into someone who can love me. But you play me like there's no tomorrow. You should know that I'm fed up with your lies, so don't come closer. You know you hurt me bad and I have scars. I need some time to heal, so don't come over. Don't even bother calling, just get lost. I'm fine on my own, so don't even bother to come back, 'cause I'm done. I'm fine on my own, and boy, your pretty little lies are getting old. All those late nights I waited for you, they're gone, 'cause we are through. All those late nights I waited for you, they're gone, 'cause we are through. Your lies are getting old, but I'm getting stronger. You think that my bed's getting cold, but it's feeling warm. Your lies are getting old, but I'm getting stronger. I'm getting stronger, 'cause I'm fine on my own. So don't even bother to come back, 'cause I'm done. I'm fine on my own, and boy, your pretty little lies are getting old. All those late nights I waited for you, they're gone, 'cause we are through. All those late nights I waited for you, they're gone, 'cause we are through. 'Cause we're through.
Kia ora. The Open Policy Meeting Session 2 will start very shortly. Please take your seats. Oh, all the silence now. Welcome again. I will leave the mic to my co-chair, Shayla, who will be doing SIG administration for the second session. Thank you.
Thank you, Burton. Hello, everyone. Welcome back to the second session of APNIC Open Policy Meeting at APNIC 58. And this is a reminder for you how we administer the policy SIG. We have Burton with us as a chair and me, Shaila, and Anupam ji as a co-chairs. So Policy-SIG Charter. Policy-SIG Charter, this charter is to develop the policies which is related to the management and use of internet number resources within the Asia Pacific region. Next slide. So this is the previous proposal. Sorry. Proposal 158, IPv6 auto allocation for each IPv4 request, which is now abandoned status. Next slide. We had received 4 proposals to discuss this time, but author of proposal 159 didn't join at the first session, so we only continued with one proposal, proposal 157, and we have dropped the proposal 159. And we also have proposal 160, which we are going to discuss this session, and we had proposal 169, which is withdrawn by the author earlier. Next slide. Okay, so this is the agenda of Open Policy Meeting 1 as a first session, which is already finished. Next slide. And this is the agenda for Open Policy Meeting 2. I am presenting SIG administration, and following that Sunny will present policy implementation report, and after that we have one proposal 160, which will be presented by Babir, and following that Secretariat Impact Assessment by Sunny. And last, there is one informational presentation on using IPv6 for Internet of Things. Next. For the newcomers, if you are interested to get involved with the Policy-SIG, first step is to subscribe to the mailing list. Okay. So the steps to implement a policy: first, you submit a proposal, then the proposal is published in the mailing list for discussion. If it reaches consensus at the Policy-SIG session, then again it has to reach consensus at the members meeting, and from there we have a comment period, and which leads to the easy endorsement, and there is another period for editorial comments, and then it's up to the APNIC Secretariat to implement it. This process can take a very long time or very short time depending on the proposal. Next. Consensus is a general agreement taking into consideration comments on the mailing list and OPM. It's not a voting system. So if you object to a proposal, you have two options. You can oppose it or you can strongly oppose it. If you're strongly opposing it, which is a major objection, you will be requested or asked to explain why you are opposing this proposal, and you have to make comment in the chat or in front of the mic. So there are also some other options like neutral support and strongly support. You can read the code of conduct, which is the link is given below. Next. For gauging consensus, we chairs consider the mailing list discussion, the discussion on OPM and AGM, and also, of course, the confer. Next. For gauging consensus, we use confer. You have to log in to confer.apnic.net, and RIR, ICANN, PTI Secretariat staff do not participate in the consensus call. That's it. Thank you, everyone. Over to you, Barton.
Thank you, Shailan. Sorry about the audio issues. So now we're moving to Sunny for a recap. Eventually, as anyone was not here during the first session for the policy implementation report, if you need to review what was said, it's all published on the website. Do we have Babir online? For Prop 160, change IPv6 initial assignment to /44 for organization eligible for multi-homing. Babir, are you online?
He was online. I have seen him earlier.
Yeah, well, whenever you want, Babir.
Yes, I'm online. Can you hear me?
Yes, please go ahead.
Is my screen visible?
Yes.
Okay. Thank you. Good morning, everyone. My name is Rafini Babir, and um, I'll be presenting a policy proposal that addresses a critical aspect of IPv6 adoption. The title of our proposal is change IPv6 initial assignment to /44 for organization eligible for multi-homing. We aim to revise the IPv6 assignment policy to better facilitate development in multi-home network. By doing so, we hope to promote broader adoption and more effective implementation of IPv6 across the APNIC region. Um, can you see the slide change? Is it okay?
Yeah.
Okay. This is a comparison graph of APNIC IPv6 allocated, advertised, and unadvertised block. Here we can see that a large number of IPv6 block are not being advertised. Among many regions, can it be any discomfort in routing for default/48 assignment? Just a question. Let's analyze this matter further. This slide represents a breakdown of IPv6 membership by industry. As you can see, more than 75% of the member are ISPs, data center, telco banks that really and heavily rely on multi-homing for failover and load balancing. So can it be possible that they are facing a discomfort in IPv6 routing if they have the default 48 assignment? Okay, let's analyze a scenario where an organization applies for a /23 IPv4 block, giving example of multi-homing or multi-site operation. After assessment, APNIC approved their request and provided /23 IPv4 block and a default 48 IPv6 block as per current policy. So my question to you for this case, is it possible to make multi-homing with a single /48 IP block without any complex networking? Why APNIC current policy does not consider the same routing flexibility for both IPv4 and IPv6 by default? And also, should we let the member dig down the APNIC website and policy for getting shorter block, or as initial assessment, to resolve their routing discomfort? Okay, let's go for a technical assessment. This demonstrated typical multi-home and multi-site network setup, highlighting the specific requirement for IPv6 prefix announcement. In this diagram, you can see multiple ISPs can be connected to multiple sites within a network. Each site is announcing a /48 IPv6 plot toward its respective ISP. As per best practice, you know, the /40 is the smallest subnet that can be advertised through eBGP for IPv6. However, to achieve effective failover and load balancing between ISP, a larger aggregated block such as a minimum A/47 is necessary. And to align with IPv6 nibble boundary addressing system, the next logical step is /44. So let's talk about the solution. First step, any application requesting a minimum /23 IPv4 block with multi-homing or multi-site scenario must be provided with a minimum of /44 IPv6 block in respective of their application of /48 or none. Second step, the information that the /44 to /36 IPv6 block can be availed with no additional fee if you purchase a /24 or a /23 IPv4 block should be reflecting at the example of fee in APNIC website. So let's see what we have in the APNIC website. Actually, this is not a part of the policy proposal, but it must be addressed. Currently, APNIC in the APNIC website, the new member fee example are showing only two options of IPv6. One is /48 and other is /23. /22. And this actually misled new member as this is the only available option of APNIC for IPv6, but it is not. So we suggesting to update this chart instead of showing only /48. We are proposing to show the range of /48 to /36, reflecting the current policy. I'm again saying reflecting the current policy that there is no additional cost for IPv6 assignment within this range when any organization pursuing a /24 or a /23 IPv4 block. Okay, let's look at the policies in the other region, specifically in ARIN. ARIN's policy specifies that the initial IPv6 assignment size is determined based on the number of sites an organization has. If an organization has more than one but fewer than or equal to 12 sites, they qualify for a /44 IPv6 assignment. Really clear cut. Okay, this slide outline our proposed IPv6 proposal change. The current policy section 8.2.1, an account holder with IPv4 allocation is eligible for a /32 IPv6 address block. An account holder with a IPv4 assignment is eligible for a /48 IPv6 address block. We suggest to update this policy by adding a new point that an account holder with an IPv4 address assignment who has a multi-home network infrastructure should be eligible for a /44 IPv6 address block. Actually, we are not suggesting to change the minimum of the IP v4 I mean the IPv6 as /48 option for all members. We are suggesting only for the multi-home scenario. And we also propose to change to the current section 9.1.1 IPv6 for multi-homing, which state an applicant is eligible to receive a portable assignment from APNIC if it is currently or planned to be multi-home. The minimum assignment made under this term is /48. We propose to change that /48 to a /44 here to ensure that no, anyone with multi-homing requirement will be provided with /44 as initial assignment. Let's consider the advantage of this proposal. It eliminates the technical limitation of /48 IPv6 assignment in multi-home infrastructure. A /44 prefix offer greater development and routing flexibility for organizations, and also it encourages IPv6 adoption and increases APNIC member self-awareness for IPv6 eligibility. And there is no known reach advantage found for this proposal. And you might already have some insight into some alternative solution in your head, I know, for this problem. So, I mean, your observation can be a /48 can be used in a multi-homing environment through some mechanism, or other can think that APNIC policy has provision to provide shorter prefix than /44 if an eligible member applies for it. Okay. For those, I can say, if you want 100% IPv6 adoption, stop complicating things for everyone. I'm again saying, if you want 100% IPv6 adoption, stop complicating things for everyone. Most people won't manage a /48 block well in the multi-home setup and won't even bother that trying. So they aren't going to dig down the APNIC website and policy for details on getting a shorter block, and that is the reality, and that's what's happening. IPv6 need to be straightforward and simple. It should be encouraging people to use it, and expecting people to find out that they can get shorter IPv6 block within the same cost is really unrealistic. This policy should simplify the process and not add more challenges. While efficient IPv4 of solution are necessary due to the shortage of IPv4, but for IPv6, that must be flexible. That should be easy for all members. It shouldn't be limited those who have the specialist skill. So that's it. You can go for the question.
Thank you, Babir. Just to make sure, the fee is not within the SIG policy scope.
Yes. I didn't discuss about the cost. I mean the fee, but I mean the cost is same as per policy. The cost is same. That's why I have to mention it. That's nothing else there.
Sunny, you want to go for the Secretariat assessment, please?
Thank you, Bertrand. I'd like to take this opportunity to actually thank the author of this proposal. He was a fellow of APNIC, and I'm very happy to see that he put forward a proposal just after one fellowship program. So thank you, Bobby, for doing this, and good luck with your proposal. We noted that the initial proposal title was different, and this version 2 is actually title is changed to multi-homing. So the assessment that we did is for version 1. And I also note that, some points were changed in version 2. Again, are they up? Thank you. Not the implementation report, it's the assessment. Anyway, it's all right. It's online, it's published, I won't take too much time to go through it. It's online. Please have a look at it. Again, that was for version 1, but it's been changed. So we haven't had the time to review the new version that's been submitted. So if you would like to see the assessment of the version 1, please have a look at it on the website. Thank you. That's okay.
Thank you, Sunny. So do we now will open the floor? Do we have any comments or questions for Babir, please? Remember to state your name and affiliation. And for those who will be using Confer, don't forget to log in now. Thank you. Please.
Hi, this is Koki Nakagawa from APNIC. I want to comment for the process to choose. This proposal is withdrawn by the author in August 31, and resubmitted September 1st. In JP region, JPOPFST is discussed on local language about the policy proposals. But in this time, we did at only version 1. We cannot did the discussion version 2. So we need to more thinking time and discussion time need to do so. I think this is a need to time more discussion. Thank you.
Thank you. Chris?
Hi there, Christopher Walker here, speaking in a personal capacity. I would like to make it known that I am neutral to this proposal, but just so the policy author is aware, members can already apply for more than a /48 under current policy. The policy doesn't explicitly state that they can only apply for a 48. And for multi-homing, I believe it would be fair to say that if a network operator was single site or multi-site, multi-homed, that they would be eligible to apply for more than a 48, and that the Secretariat may approve that.
Thank you. And on top of that, if you ask for a multi-homing, you'll get straight away a /47, and you'll have to request to have a /44. Any more comments, questions? Tomohiro-san.
Hi, my name is Tomohiro Fujisaki from the NTT Communications, but speaking in my personal capacity. But I oppose this proposal because they also think they basically announce one block to divide to several blocks. That's not a good thing. So actually, in the policy text, aggregation is so important. The policy text says the aggregation is so important, so I oppose this proposal. Yeah.
Thank you. Anyone else? If there's no more questions or comment for this proposal, I will continue with the consensus call. So this proposal has been discussed on the APNIC policy SIG mailing list, and just now on the OPM. The PDP requires the community to reach a general consensus agreement before it can proceed. So remember to log in on Confer, and I guess Confer should be online somewhere. Yep, got it now. So for the consensus call, you'll be given the opportunity to indicate whether you strongly support this proposal, you're neutral to it, or if you object the proposal, strongly oppose this proposal. And again, if you strongly oppose this proposal, I will ask you to step up and explain why. Sorry. So for those of you who strongly support this proposal, please raise your hand. That was easy. If you support this proposal, please raise your hand. If you are neutral to this proposal, please raise your hand. Thank you. If you oppose this proposal, please raise your hand. And thank you. And if you strongly oppose this proposal, please raise your hand. Thank you. You'll have to step up and explain why you strongly oppose this proposal.
Hello, I'm Teddy from APNIC, Indonesia. I just want to make a simple recent. So the matrix is totally different between IPv6 and IPv4. That's the reason why I oppose, because it's not proportionally to make multi-hopping with those kind of slicing slash policy among or between IPv4 and IPv6. That's it. So IPv6 is very totally different metrics. We have to make a limitation. Thank you.
Thank you. So I will now chat with my co-chairs and get back to you very shortly. We have a comment on Zoom.
Yes, George Adagi from APNIC. Liam Stevens says, whilst I agree with the primary intent of the policy proposal to encourage IPv6 uptake, and the presentation and the passion of the author is excellent, I'm concerned that a /44 could be excessive in most cases. A /47 would suffice for multi-homing, and I would be more agreeable with this suggestion. As has been stated already, members are able to request a /44 if necessary.
Thank you. Sorry about that. Seems that I've lost one of my co-chairs. So I've conferred with my co-chairs, or my co-chair actually, because one is lost in the midst of internet, and noted the community's comment in for and against the adoption of this proposal. And on consideration of these inputs, we believe that the community has not reached a consensus on this proposal. And so now we will be sending back this proposal to the mailing list and encourage the author to take into consideration everything that was said by the community as a good feedback, as always. And if he wants to continue with this proposal, we will see it again at the next OPM. Babia, what's your will on this? Will you carry on with the proposal or will you abandon it?
Yeah, actually, I have seen very less strongly opposed for this proposal, and what they're saying, I mean, by opposing the proposal, I already answered this question in my presentation. So I thought it can be a consideration for if you want IPv6 deployment for this community. Because if anyone is showing issues that they're having some discomfort for IPv6, we should mention it. We should work for it. Because we all want 100% deployment of IPv6. So that's what I can say. So I don't know why it's not getting accepted, but I think I will try to continue.
So my recommendation to you is to take into account everything that was said during the OPM and on the mailing list and use that feedback to amend your proposal for the next OPM. And again, thank you very much for your proposal.
Thank you. Thank you, everyone.
So we'll carry on. And next we have Benny, who will be presenting an informal on using IPv6 for the Internet of Things. And that's a reminder for those who were not at the BOF 2 days ago, sorry.
Thank you. Yeah. Hello, everyone. Yeah. My name is Guangliang Pen, and people also call me G Pen or Benny. Yeah. Before I start the presentation, I would like to thanks to New Zealand and also thanks to APNIC. And I just give some bit background on myself, and which also related to this presentation as well. 30 years ago, I actually came to New Zealand and studied information technology at the University of Waikato. New Zealand people call themselves Kiwi. They are very friendly people. They gave me a lot of support when I first arrived in New Zealand. I believe all of you will feel they are very friendly in the last few days, right? Yeah. So at the time I studied in Waikato University, it was very earliest years in the internet development. And Waikato University was a connection point connecting New Zealand to the global internet. And Waikato University also acting as an NSET link, actually managed the IP address delegates to the organization in New Zealand. And we also built the first national digital library in our lab called New Zealand Digital Library. So I learned a lot from the university and the teachers and from the university, and very thank you to the New Zealand people and give me all the support during my study in New Zealand. So I want to say thank you to New Zealand. And when I come back here after 30 years, so very appreciate it. And second, I also want to thanks to APNIC. I joined the APNIC secretary in 2000. It was 24 years ago. And I worked for APNIC as a host master, and then promoted to the head of the host master, or called registration service manager. And I service the members, and a lot of members knows me as the registration service manager. And I presented a lot of presentation in this policy state in the past, but it's on behalf of the APNIC secretary. But today is not, because I have actually left APNIC since this year. So today, my presentation will be in my personal capacity as an independent consultant on IPv6, IoT, and AI. So I'm no longer represent APNIC secretary, so just make it clear. And today's presentation is totally on my personal capacity. I really want to thank the APNIC members and APNIC communities and allow me to service you in the last 24 years. And I will use this opportunity to say thank you. And also thank you to all the ex-APNIC staff. They are very, very friendly. I believe you also feel that in the last few days. Yeah, thank you so much. Now I think we should start my presentation. We originally actually make a policy proposal, POP 161, and using IPv6 for Internet of Things. And why we making this proposal? Since I left APNIC and I communicated with the IoT industry, and I found actually most of them not using IPv6 at this stage, to be honest. And even electrically or non-electrically, they have a lot of ways, different ways to use in the IoT industry, but not really using IPv6 at this stage. And I actually want to bring IPv6 with the IoT industry together because they have a lead between each others. And the original proposal was like IPv6 can be allocated to Internet of Things for electronic smart device and or for hosting information of non-electronic items on the internet. That I actually want to add it to the policy to make it clear, like IPv6 can be allocated to IoT things. And also will help the IoT industry to easy to require IPv6 from APNIC. This was the original proposal and objective. The key requirement of the IPv6 proposal is to using IPv6 for non-electronic items. That actually very new to a lot of people. But in some of the case in the IoT industry, they do need use IPv6 to host those information for the non-electronic items on the internet. So they can always check them online to make sure like the information is available for the item. That is some of the case. And that is very interesting and very active discussion after I make the proposal and on the policy mailing list. And a lot of people may be reacted as no, we will never use IPv6 for non-electronic device or non-electronic items. So they think, oh, probably not possible. But after all the discussion, I'm not sure everyone watched the mailing list, but if not, I will just a quick summary. After the discussion, the people believe IPv6 address to host information for non-electronic item on the internet actually is acceptable in the current policy. So there's no need to change the policy at this stage. Based on this point, so we decided maybe we change this proposal to informational presentation. And so we can share the information with the APNIC community and how this work. And actually, maybe in the future, this maybe can work together with the IoT industry, with APNIC. So at this presentation, we don't seek any consensus for the policy proposal. We actually withdraw the proposal, but make it as a informational presentation. And the objective of this presentation is just to share information. It's not arguing or like change the policy. So internet of everything by IPv6. That is actually our goal or where we want to achieve in the future. Like assign single IP address for those electrical smart device that actually then bring the electrical device can be connected to the internet and do one-to-one direct communication. And also we trying to mapping like single IPv6 to those non-electronic items and host the information on the internet, and then you can check them anytime. And it is a real internet of everything. We want electronic or non-electronic item also connect to the internet. That is what we want in the future. But this may be very new or may be shocking to you, and why we're thinking of this. I think like 1,000 years ago, I don't know if anyone talking about mobile phone, right? And 500 years ago, I don't know if anyone talking about internet. Something never happened in the past. You can't say it will never happen in the future. So today we just think like maybe we can change something, and we can work together and see if something is good for the internet. And I really like the sentences say, we don't ask like what the internet can do for us. We ask what we can do for the internet. Sometimes our thinking or our contribution or our like work together can change the internet in the future. And why we use IPv6 as a key to identify the non-electronic items? I think during the mailing list discussion, there's so many ways to do it. I also actually talked to the people in New Zealand, like the Internet of Things Alliance and the chair, and I actually fully understand there's many ways to do that without IPv6 at this stage. And if we want to move to IPv6, actually it's a long way to go as well. It's probably not same as IPv4 transits to IPv6. We take 20 years. Well, we haven't all on IPv6 at this stage. So why we use IPv6? Actually, now in the internet, we're using IPv4 and IPv6, right? And IPv4 is running out. So the only way we can do is IPv6. And IPv6 is routable compared to other identity numbers, right? If you have your driver license, if you put your driver license number on the internet, it's come out. You can't ping it. You can't ping your driver license. But if there's an IPv6 address, you can ping it. Technically, you can ping to it. So that is something is different. And like with the IRWIS database, or we call APNIC database here, so the information will tell you which company has which port of IPv6 address. And also with the secure routing, like we're using PKI, and then we'll ensure only the company has that IP address port and route it. So the customer can charge the responding IPv6 address is from the factory or the organization actually owning that item, right? Because we can see when you scan it, you can see the responding IP address. It shows you the IPv6 address, and based on APNIC database, it will tell you which company owns this IP address, and also, and based on the security routing, and we ensure that routing is actually from that company, except some hijack, of course. We never able to like completely avoid hijack. Some people may hijack, but it is not on this topic. And another one is like due to the huge number of IPv6 address, like you really hard to guess which IP address assigned to which item. For example, like you pick 6 number from 42 number to win a lotto. It is very difficult already, right? Random picking number from 42, like picking 6 number is difficult. And how you image picking one number from 18 billion or billions numbers in a /64. 1/64 IPv6 has 18 billion or billion numbers. So you are very difficult to guess which number been used. If you actually trying to figure out, you put a number and then the system will tell you this IP has not been assigned. So the people will say this is a fake product, right? But if you want to make a copy, then will be many like item use the same number. Then the tracking system say, how come this item been sold for multiple time or in different place? So we also then will notify there's a fake product. So like if I learn each item mapping with IPv6 address, that is why we think it will probably have to stop this fake product. I think this is just a new idea, and I would like to ask my friend Wei Wang to give you more detail on how this can be implemented and how this some of the idea or practice at this stage. Yeah. Okay.
Thanks, everyone. My name is Wei Wang. I'm basically a DNS guy. I worked for in APNIC over 10 years, and I engaged ICANN a lot, especially on the IDN, the International Domain Name. But in the recent past 5 years, I've been working on the IoT identifier. And then I realized the IPv6 address could be applied to the IoT scenario. And we do have some enterprise users requirements, and then we found a solution for them. So and I talked with Guang Liang, and we submitted a proposal. Of course, we encountered active discussion or intensive debate in the mailing list. But anyway, I'm very grateful to have this opportunity to bring more details about the issue. The first slide is about IPv4 send. If we recall, right, and it's recorded, of course, it is recorded in the Wikipedia that at the very beginning, like 20 or 30 years ago, it was like if the Earth was made up entirely out of 1 cubic millimeter grams of sand, then you could give a unique IPv6 address to each grain in 300 million planets the size of the Earth. It seems like either the sand in the Earth or the sand in the planet of Arrakis could get the IPv6 address. But of course, the IPv6 address cannot be configured onto the sand because it's not electronic. It doesn't have any interface to assign to. But to remember that the sand on the planet for Arrakis is not sand, it's spice, right? It's a valuable material in the universe. So it is basically a commercial product. Then it has a value. And even the sand on the Earth could be put into the bottle or packed in the bag, become a commercial product. Then it needs an identifier to identify itself. So maybe the IPv6 address could be utilized as an identifier to help the enterprise users to realize the identification, verification, and tracing. So let's take a look at the IPv6 address. So basically, I think at the very beginning, IPv6 address, along with the IPv4, are supposed to configure onto the electronic devices, the server, the router, the switch. But however, in the RFC 4291, it's also mentioned that a single interface may also have multiple IPv6 addresses of any type. So that's why we have scenario that we can assign the IPv6 not only to the bare metal, but also we can assign the IPv6 address to the virtual network, to the virtual host over Apache, assign the IPv6 address to the VMware, to the VM, to the container, or to any services. Also, I think IPv6, the IPv6 protocol is compatible with the other IoT identifier. That's why we have the paper. We have lots of papers talking about how to mapping the EPC identifier to the IPv6 address. This graph is illustrated how to mapping the RFID tag to IPv6 address. Then we have some other applications like this paper. They introduced how to use MD5 to map the content name into IPv6 address. Of course, mapping is about how to map the content name into the interface ID into the second 46-bit. And we have another interesting paper about how to generate the IPv6 address for Bitcoin wallet using the CGA to secure the IPv6 address used by the Bitcoin wallet. So all these papers and researchers, they explore the possibility to make full use of the IPv6 namespace. Given that we have 128 bits, it's a little bit waste if we only use the first 48 or 40, the first 64 bits. Then let's look at the IoT device. Basically, the IoT device needs multiple identifier to realize different functions. The first one, the left one is the front page. It's a picture from the front that it needs. There is a Wi-Fi model embedded in the device, and of course, you have a MAC address. Then it will have an IPv6 address from the DHCP. The IPv6 address will help the device communicate with the backend system to interact with the backend system to upload the data it cached. However, at the bottom of the device, it has another two identifier. One is a QR code, one is another barcode. QR code, maybe if you scan it, you will get a URL. The URL will enable you to have access entry to visit, to access information from the backend system, which means, anyway, the IoT device, they need diverse identifier to realize diverse functions. However, there are challenges to the non-electronic item identifier. When I talk about when I say non-electronic identifier, what I mean is the right page, the right graph. Okay. The question is about how do we realize the universal accessibility? Because for most non-electronic identifier like handle or JS1 or RFID tag or something else, it's more like a sequence number, right? So we have only two options. The enterprise users have two options. One is to use a dedicated client tool or plugin or third-party software to recognize the semantic of this label and access corresponding information. The second option is that we assemble the label into a URL. Then we can use the operation system or any other applications to access it. The example is about how do we access a handle, right? The blue label is about a handle, what a handle look like, a DOI look like. It started with 10.19366. Okay, but we have no idea how to access it. If you input this label into the browser or into the Google search engine, it may tell you give you a URL to the CNR, to the handle webpage, or it doesn't recognize it. If we want to access it, we have to add a domain name in front of it to assemble a full URL. Then the enterprise customers, administrators, or the consumers have the ability, able to access the corresponding information. But this method, they have some, problems. They expose the internal semantic meanings to the public, which make the counterfeiter easy to fake it or to build up a website phishing to simulate the real one. And it depends on the external third-party system. It depends on a external handle system. I mean, the enterprise or manufacturers, they have no control of the whole query flow. And in most cases, the enterprise users have multiple identifier. They have their internal ID to conduct the internal manufacturing process management or the post-sale management. But on the other hand, they need to be compliant with government regulation. They need to introduce, they need to print some other labels on identifier on the product, on the items. They need a one label to co-work with all the other multiple labels. And of course, if the label could prove that it is a real one, it has ability to self-verify itself, it would be much better. So the real demand from the enterprise customers is that they need a access query label or identifier compatible with all existing various types of identifiers. And of course, they need a random sequence label, which make the counterfeiter really hard to predict which one is the next one. And the enterprise users, they need control, a gateway that controlled by itself, and could redirect the query to any third-party upper layer applications system. And they wanted the label, the access entry could be supported by any operating system or third-party application software without installing any special plugin. Of course, they need the ability to self-verify the code is a real one. So that's why we introduced IPv6 address into this industry. As I mentioned, there are a lot of papers and researches about how to generate the IPv6 from content name, from RFID, from Bitcoin wallet address. And what do we suggest to our customers is just that you can simply map your internal identifier into the at least you can map it into the second 64 bits. Then you can ask your administrator or the consumers to visit the URL, just simply direct visit to the IPv6 address, and it will go to a system, based on the BGP and casting, and it will go to a third layer gateway, which will redirect the query to any arbitrary up layer ID system or application system. The benefits is obviously that the enterprise users have the massive non-sequential addresses, and the address is the accessing identification, and the routing path is the verification path. Given that we have the RPKI and the BGP-SEC, the query flow is a traffic flow. And of course, we will have a global acceptance and reachability. So the solution is basically it's not a brand new one. It's basically a package of all the existing RFCs and technologies. And it is compliant with the IETF standards framework and has been deployed by the local customers on their IPv6 addresses. I mean, the legitimate IPv6 addresses in both experimental and live network environment. So there are something left to be still need to be done to be researched. That there are three outstanding issues. The first one is if we need to encourage the enterprise users to use only use second 46, the last 64 bits, or we could encourage them to use a little bit more of the naming space, like maybe like 94 or more. Another thing is that we can leveraging the RPKI as well as the BGP-SEC to secure the routing paths of this kind of query. And also for the first part, for the network ID. And of course, we can leverage the CGA to secure the interface part. The CGA was created at the very beginning to bind a public signature key to a IPv6 address. I mean, especially for to the last 64 bits in the send protocol. We tentatively employ the original IoT identifier as a modifier parameter along with the other parameters to generate the IPv6 address by CGA generation method, which will enable the enterprise users to assemble a URL, including the IPv6 address and a token, a secret, encrypted token by the private key, which will secure the access. Another thing is about the RPKI and RTA. Of course, given that the RPKI have already provided a mechanism to secure the BGP broadcasting and to secure the ownership of the IPv6 address, if we could make an extension to that, make a little bit extension to the data format to include the IoT usage, description or the necessary graphs or IoT lifecycle, all this information to the database, that will help the consumers or other commercial partners have a better information control of the whole IoT lifecycle. So that's the end of the slides. I would also like to emphasize again that this is just it was not a creative invention, but it was more like an integration solution to help the enterprise users to address their concerns about the IoT product management in the logistics and in the manufacturing process. Thank you. Thanks again.
So, thank you. Does anyone have any questions or comment for Wei or Benny? Nope. Thank you.
Thank you.
Can I make some questions for
please
the presenters? Thank you very much, JPNIC, Akinori Maimura from JPNIC. Thank you very much for thought-provoking presentation. One question to Guangdian. I think you said in the presentation that, yeah, I remember the discussion was going on in the SIG policy mailing list, but I didn't follow everything. Then I don't remember what the reason why your policy proposal don't need amendment of the policy to put the IPv6 address to the non-electronic articles. I don't get it. I don't get that.
You mean like why we don't need the policy proposal anymore, right? Actually, basically at the beginning, we want to make the policy proposal, but after discuss and they believe the current policy actually is now using IPv6 address to host the information on the internet. That actually is an acceptable use case for IPv6. That is the reason they believe the current policy actually can cover that part. So, and there's no need to change the policy proposal.
Right.
And this is the key point. And another thing, it is like another point is when you receive a /32, it actually is default allocation. Then it's a huge number of /64.
Exactly.
And each 64 has a huge number of IPv6 address.
Yeah.
And you can actually use one of the 64 to do this part, but it's enough.
Right.
Basically, a company only need a /64. They can identify all the product in many years.
Yeah.
So when you use the allocation policy to get a /32 for other purpose, for your company network or for anything for the normal allocation, and you can slightly use one /64
Yeah.
to do what you want, and there's no need to change the policy.
Okay.
And also, when you use that /64 to hosting information on the internet, actually it's also a valid reason. And they can actually hosting one-on-one, but it's one-on-one, one IPv6 hosting one item.
Right.
And when that item on somewhere, like for example, you scan
Right.
your glass, whenever you scan it, you know that glass, the IP address will tell you what this glass is made from and when they sold it and all the information about that. So that actually, it is something virtually, actually that connect to the internet. But in fact, the IP address is using on the internet. It's in the server, hosting the information of that glass.
Yeah, I was doing my quick math in my smartphone, and it says that the entire globe, each square millimeters to put one IP address, then that we need 65 bits. Then that's actually really doable, I think. Then thank you very much. This really interesting presentation, which require me much more further thinking. Thank you very much.
Thank you, Mamura-san, for the comment. And also, I just want to enforce that IPv6 actually has a huge number. We don't need to be so worried about IPv6 one now, because even 160/64 actually is enough for one company for many, many years. And they don't need to do recycling for that /64 because there's 18 billion IPv6 address in that /64. So I think that's don't worry about because this proposal, this presentation and lead to the V6 running out. But a lot of cases actually raise IPv6, but not on this case. Yeah. Thank you so much. Any questions?
Thank you, Benny.
Thank you.
And if needed, you can use 2/64.
Yeah, that's good point. Actually, we can apply for a /48. A company can a /48 is good enough.
Yeah.
They have plenty of /64 already.
I have a /48 at home, and I'm using 2/64 for the home automation. So there you go.
Okay,
Have a
thank you.
comment?
Hi.
Yeah, please.
I'm Vijay Varadarajan from University of Newcastle in Australia. I just want to make one, I enjoyed your presentation. I just got one comment on this. You showed a few papers, some of which I'm familiar with. And so, you said the last 64 bits can be used for the interface ID, so on. But there's a whole area of work called named data networks, NDN, where you will be able to, instead of, see, all these addresses, IP addresses are identifying the location, the container. But, the data-centric approach, or you had one paper saying content-centric approach here, that whole thing is about, pointing to a data item, information item. So I can refer to a Netflix movie clip of Rocky, the third minute of the clip. So that area has been developing since, I don't know, maybe 2008, 2009, in the next generation of internet, which started 15 years ago. So what the scheme you said was it actually combines. It says, look, I have a data item, and they have hierarchical naming type thing to do it, and the routing is different. The way they route these things in there is different to normal standard IP routing. But I can map that data item into using an IP address. That's what you said. So my comment is somewhat orthogonal. So what I wanted to ask you, or sort of think about sometime later, is have a look at this named data networks, which has a complete a way of addressing unique data items and routing them without the need to have this type of IP type addressing. That's my comment. Thank you.
Okay, thank you for your comment. Do you have any comment? Or I think just talking about the routing, just want to make it clear, we're not routing single IPv6 address. To be honest, we only allow routing on /32 level. If they got a /32 or they got a /48, they will route /48. And basically probably not routing into /64 as well. But we will be aggregated on routing. But just use one part of the /32 or /48 to be used as identity or hosting the information for those non-electronic items. Yeah.
And one quick response that the solution is not supposed to replace all the other IoT identifiers. It just help them to realize more trustworthy routing paths. Once a packet goes to the gateway, all the work about IPv6 has been done. The rest of the work will be redirected to the upper level application level. So, yeah.
Related to IoT, it is related to content.
Yeah. And beside the IoT, and think about the metaverse, or yes, everything could be basically the sand in the metaverse could assign IPv6, right? Everything could be built based on the IPv6. Thank you.
Okay, I think thank you all the comments. I think maybe this is a new idea. Maybe you need to have a deep thinking before you actually accept that idea. Yeah, but thank you so much, everyone. Actually, also thank you all the comments. I try to thank you for all the comments from the mailing list as well. I think you bring up even you object the proposal or even you against it or whatever, but it's very good for this improve. And actually, we work together to shape the future internet. We try to get the good things for all the people. Yeah, thank you so much.
Thank you, Benny. And that leads us to the end of this session. I guess, let me check. Yep. So I would like to thank you all. You have a comment? Yes, please.
Hello, my name is Jarong. If you have not met me, I'm the incoming Director General for APNIC. And it's my first time in this capacity joining the policy SIG. And I'd like to take this opportunity to thank everybody. APNIC's policy making is a core part of APNIC's work. I mentioned in my opening that we need to be able to deliver timely, relevant policies coming from the community that's with inclusive voices to really allow us to stay relevant and keep up with the challenges that's coming. So I think one example about the IPv6 for IoT is a good illustration of some of this discourse. And we welcome discourse. That's the whole idea of having a platform for us to be discussing this. So again, a big shout out to ask everyone to keep participating, keep contributing. And in this community, the more we are all participating, and we always keep to the principle of why we want everyone to participate, the principle of, as a large group, that rationality prevails, and that we can have a debate, an intellectual debate sometimes, and that we are also accountable to one another. And in this regard, I also want to do a big shout out to Bertrand and the co-chairs, Anupam and Shaila, for leading the community and for facilitating this discourse, which sometimes can be very messy, especially when outsiders look at it. But out of all this very messy discussion, we put together policies that allow us to continue to function and to keep the internet together and allow us to perform our key tasks and key role in the internet ecosystem. So please join me to thank the chair and the co-chairs for all that work. It's a lot of time, volunteer time. And thank you everybody for participating, and I hope that we can continue to work together and help each other. Thank you very much.
Thank you. Well, so that was the word of the end. And so it's time to wrap up, and maybe we can have some lunch. So thank you, everyone, and kia ora.
You there? Hello? I am going to call your mommy.
I could be raw, I could be tall. I make you feel real uncomfortable. Can give you my finger, but not my hand. I won't do your silly little dance. Don't need hugs, done with the chores. I know your next move. I can be calm, moving fast. Catch if you can, and I'm happy you can't stand it. Make me high then low. Told me let's take it slow. Next thing that I know, you got a next best hoe. Summer soon, body snows, yeah. Soon too, you'll find out that